So to kind of finish out our similarity unit, today we're going to talk about dilations. A dilation is a transformation where the image of a figure is similar to the original or the pre-image. Now, we have mentioned and done a little bit with dilations, but we're going to dive in a little bit more than what we did before. With a dilation, there's going to be a scale factor. This scale factor is the ratio of corresponding parts. But it's very important with dilations that we make sure that we are always doing the prime over the original. All right, because the picture's either getting bigger or it's getting smaller. You're going to see the letter K used to represent scale factor. I don't know why, any more than why they use little m to represent slope, but when I do write the scale factor for dilations, you'll see me put K equals. Now, there's different ways that you're going to see the dilation. All right. You might see these dotted lines like that are on this first picture. These dotted lines go from corresponding point to corresponding point. And what will happen is if we drew all of them in, they would intersect at this point C, C representing the center of the dilation. All right. So another way to find scale factor is to do the distance from that center to the prime over the distance from the center to the original. All right, again, prime over original. So when you look at these pictures, just look real careful at first. All right, the way things are labeled, here's the P prime. So that means the one with the normal P is the pre-image, the first picture. The one with the prime is always the second. So our picture is definitely getting smaller. This is called a reduction. All right. Now you'll notice the dotted lines that connect these corresponding points are drawn in, and then we've given some distances on these lines. So we know the distance from the center to the prime, and then we also know the distance from the center all the way to the original. We'd have to add these parts together. That would be 7. So if you're asked to find the scale factor, again, I'm just writing this down, prime over original. So that means I want the distance to the prime picture, which in this case would be 4, over the distance to the original, which is the total of 7. We know the picture is getting smaller. We know that it's a reduction. So notice we want to make sure our scale factor represents a number less than 1. And 4/7 is less than 1. All right, you always want to make sure you have that agreement. All right, the next picture looks very similar. No normal letters, no prime, but we are told that the little triangle this time is the pre-image. So I'll put the P in there. And then the larger one is the image, so that's the P prime. So this time the picture is getting larger. We call that an enlargement. But again, to find the scale factor, we've got some distances labeled going from C all the way to the prime. So we'd have to put these parts together. That's a total of 12. And then we've got the distance from C to the original, which is just the 8. So when we go to find the scale factor, we would do the distance to the prime over the distance to the original. You always reduce. Again, I remind you, if I were to type 12 divided by 8 into my graphing calculator, and then I go into math, and then hit enter twice, math, enter, enter, that will reduce this, both are divisible by 4, to 3/2. If you're working with an enlargement, your scale factor should be a number greater than 1. So of course, 3/2 is like 1.5, so that is bigger than 1. So we have that agreement. All right. So in these bottom pictures, 2 examples, we want to find the scale factors. All right, look at how these are labeled. Here, all the vertices are labeled. We've got normal letters here and prime here. So that means this is the pre-image. and the prime is the image. To get the scale factor, it's the distance to the prime over the distance to the original. So if I find this distance to the prime, I'm going to add these parts together. That's 5. And then the distance to the original is just 3. I'm just going to check. I do see my picture's getting bigger. It's an enlargement, so that scale factor makes sense. It is larger than 1. Over here, again, it's the vertices that are labeled. We've got normal letters and prime letters. So I notice this time my picture's getting smaller. So this is a reduction. To get the scale factor, all right. Now, this time they didn't give me numbers on the dotted lines. They actually gave me numbers on the picture. And that's fine. We still want then prime over original. So I'm just going to pull one number off my prime picture. For instance, I'm going to grab 3. All right. That goes with A prime, B prime. So if that's the side I'm grabbing off the prime picture, then I need the normal side AB on the larger. So I'm going to do 3 over 12, and that reduces to 1. Whoops, slide it into 1/4. All right. I could have grabbed the 2 and put the 2 over the 8. That still would have been 1/4. I could have put the 4 over the 16. That still would have been 1/4. As long as I make sure I grab corresponding parts, it's always the prime side over the original side. And again, we know it's a reduction. We have a K value less than 1, so we have that agreement. All right. Example 3 wants us to find the scale factor and solve for x. So here we are, we're back to having numbers on the dotted line. So if I look at my picture, I see the smaller flower is P and the larger one is P prime. So I know that this is an enlargement. I'm just going to write that down. Even though they didn't ask for that, it helps me know that when I get my K value, I should have a number greater than 1. All right, so we need the distance to the prime. So I'll add those two parts together. That will be 18 over the distance to the original, which is just the 12. All right, so we're going to get 9 over 6 or 3 over 2 again. All right, that I have agreement because that's a number larger than 1. All right, I obviously couldn't have used this side because that's where my missing part is. So make sure that you are working with parts where you've got all the values. Now to solve for x, just picture this as being similar triangles. All right, so I can do the side splitter theorem. So if I just kind of pretended that this little flower was extended, I've got a fraction up here on the left side. I could do 6 over the 12. And then I'm going to come down here then and do 5 over the x. Okay. And then when I cross multiply, we get 6x equals 60. So x will be 10. All right. Number 4. Looking at my picture, I'm going from the larger oval to the smaller. So this is a reduction. So to find my scale factor, I need the distance to the prime over the distance to the original. Can't use this top dotted line. That's where my variables are. So I'll come down here. So I've got distance to the prime, which is 4, over the distance to the original. Again, add those together, so we get 12. So my scale factor is really 1/3. That makes sense because it's a value less than 1. All right, again, to do the solve for the variable, just do the side splitter. So I've got y plus 3 over y. So I'll come across, and the 8 goes with the y plus 3, and the 4 goes with the y. Cross multiply, we're going to have 8y equals 4y plus 12. Subtract the 4y and divide by 4. So y will be 3. Okay. Number 5, it says without graphing, we want to determine the coordinates of a figure, little typo there, with vertices A, B, and C, and it's dilated by a scale factor of 3. Now this is kind of review of what we did before. All right, if my scale factor is 3, all right, all I need to do to get my A prime, B prime, and C prime is to multiply all of these numbers in the original points by the scale factor. So if I multiply -3 by 3 and 2 by 3, then my A prime becomes -9, 6. If I do the same with B, I'm going to have 3, 9. If I do the same with C, I'm going to have 6, -3. All right, so all we did is you multiply the K by each coordinate. Okay. All right, let's look at number 6. This one we do actually have a grid. It says determine the coordinates of the figure below after it is dilated by a factor of K equals 1/2, and then they want us to graph it. All right, so let's take a second and let's identify what our original A, B, and C order pairs are. A, if I look at my grid, back to -4 up to 5. So -4, 5. B is over 6 up 3. And C is going to be 0, -6. If the scale factor is 1/2, you are going to multiply all these numbers then by 1/2, or in this case, we can look at it as just dividing by 2. So to get A prime, B prime, and C prime, I'm going to divide by 2. So -4 divided by 2 is -2, and 5 divided by 2 is going to give me 2.5, or 5/2. All right, for graphing purposes, decimals will actually work a little easier when we go to plot the points. All right, 6 divided by 2 is 3. 3 divided by 2 is 1.5, 1.5. 0 divided by 2 is still 0. -6 divided by 2 is -3. So these are the coordinates, A prime, B prime, C prime, after it's dilated, and then they want us to graph and make the triangle. All right, so we'll go back to up 2.5. That's A prime. Over 3, up 1.5. There's B prime. And then down to -3, that's C prime. All right, and the importance of doing this is that you can see whether or not the two triangles truly are similar. They should be the same shape, just different sizes. Okay, all right, you should be ready to practice.